I have to admit, I'm a never nester. I know, shocking. But there are more of us than you think. Dozens. Even Linus Torvalds is one. I mean, I haven't asked him, but I'll show you what I mean in a little bit. You might be wondering, well, what is a never nester? A never nester never nests their code. Okay, not never, but we do have a disgustometer which grows uncontrollably as the number of tabs go up. Nesting code is when you add more inner blocks to a function. We'll consider each open brace to be adding one more depth to the function. So this function is 1 deep because there's no inner blocks. And if we add an if statement, we've made it 2 deep. If we add a loop, we've now made this function 3 deep. And this, my fellow programmers, is the maximum a never nester can handle. A never nester doesn't dare to go 4 deep. Now the perverse among you might wonder what 4 deep even looks like. And while it brings me great pain to do, I understand that I must show you, for science. Here is 4 deep. We've now taken a reasonably readable function and dramatically increased the amount of conditions your brain must simultaneously hold. But what can we do about it? Well, there's 2 methods you can use to denest. Extraction. This is where you pull out part of the function into its own function. And inversion, which is simply flipping conditions and switching to an early return. Let's look at extraction first. We can extract the inner part of the loop into its own function. Now, we can apply inversion. When you put the happy path of code within deeper and deeper blocks, it creates a lot of nesting. Instead, we'll invert the condition and put the unhappy first. First, we'll flip our if-else by inverting the condition. Now, since we can return here, we know that the else block isn't actually needed. So we can flatten our else into the main level. Now, if we hit our unhappy case condition here, we simply get out of the way. And then the main part of the code can do its job. When you have a lot of conditions to check like this, we can apply inversion over and over again. And we end up with a sort of validation gatekeeping section of the code, which sort of declares the requirements of the function. And then we have the crux of the real functionality here. And you'll notice that the happy path moves down the function, and all of the error paths, they're indented. When reading this code, I find I can mentally discard the condition and focus on the core code, versus when it's nested, I find myself having to hold these ideas in my head. I'm curious if you experience the same thing. Let's look at a larger example. Alright, look at this beauty. Before we go refactoring it, let me walk you through what's happening. The goal of this code is to download a bunch of files from the web. It talks with this download class that we can't alter. It's an async download, so when we start the download, we have to call process over and over again. And each time it gives you one of these results. If it returns in progress, we'll need to keep calling process more. On top of that, we want to download multiple files at once in the background. So we've created a thread that manages all of them. The way new downloads enter the system is through this append download method, which puts the requested URLs onto a queue. The thread then wakes up and grabs the URLs from the queue, and then adds them to this list of current downloads. Each download is given a state, which is either pending, in progress, or complete. So on each cycle of the main loop, the thread walks through each download and checks what it needs to do with it. If it's pending, we start a new download. If it's complete, we simply remove it from the list. If it's in progress, we call that process method we mentioned earlier and figure out what's happening with the download. If it's completed successfully, we mark it as complete so it can get removed from the list. and in progress means we do nothing because it's still ongoing. But things get interesting if we hit an error. If the connection was okay, but we got an unhappy HTTP response, we determine whether the error is retryable. If it is, we retry up to 3 times, setting the download back to pending. Once it's failed plenty, we eject it from our download list and push it to a failure queue for someone else to deal with. For a connection error, we retry 3 times. Then we set this special connection disabled flag. And this causes us to basically give up on every download and clear the list. Okay, so there's a lot going on here, and it's all heavily nested in this function, which makes it hard to follow. So let's apply extraction and inversion to flatten. The first 2 big candidates here are the 2 big branches of download processing, pending and in progress. So let's extract these out. We'll move the pending part to process pending. And in progress to process in progress. That's a bit better. But this in progress function is still too deep for my liking. The worst offender is this HTTP error section, so let's move that out as well. Now, we'll keep extracting further in our run function. We have 4 major sections of our code, where we process incoming requests from the queue, where we deal with our current downloads, where we clear out the in-progress downloads, and where we wait for the signal that there's new downloads to look at. So let's do it. So now, our main function clearly outlines the steps that are happening. You can see the high-level logic I described before. And if you were to dig into any of these functions, they're also concise. At the beginning of this video, I mentioned that Linus Torvalds is a suspected never nester. And I say this because in the Linux kernel style guidelines, they state, if you need more than 3 levels of indentation, you're screwed anyway, and should fix your program. The kernel dudes are always so dramatic. They visually enforce this by making the tab size 8 characters wide. This is what 8 characters look like with heavy nesting. Yeah. I'll admit, I'm not that committed to the cause, but I am into limiting indentation. I believe that constraining how much you nest forces you to write better code. If you notice, instead of one large function that handles many things, we now have small, concise functions that have one responsibility. What do you think?